So yesterday we were talking about constraints. So we have seen what we mean by domain constraints, right? The thing that you apply to columns. So we saw four types of constraints, right? Your unique constraint, not null, check and default constraints, right? So now the next constraints are called referential integrity constraints, right? So basically it is kind of, it tells you how to go about creating tables, right? Creating in the sense, how do you decide, how do you decide to have columns in your data type, in your table, right? So the key constraint, so we have two types of constraints. We have domain constraints and the key constraints. Right. So here, the key constraint says, so here we saw not null, unique, default, and check, right? So the key constraint says that when you are defining a table, right? So when we are creating a table, there should be at least one column, right? At least one column which can uniquely identify a record. Identify a record, right? So what this means is, see, whenever we create a table, right? So for the first thing that we created was a ID, right? When you create students table, we created a student ID. When we created patients table, we created patient ID, right? If you have an authors table, you have author ID. So the reason that we have this ID, right? So everything else is a property of the student. The name is the property of a student, age is the property of a student. This has been specifically created so that you can identify a student uniquely. So there might be two people in your class, right? So there might be two Toms who are same age, right? Because you are all classmates. So two Toms might be there in the same class. But there should be some column here, right? So that I can differentiate this term from this term. If I don't have this column, right, there is no way for me to, let's say there is something called course also, right? All of them studying the same course, right? In the same class, same age group. So let's say this term wants to change his course from MySQL to analytics. There is no way for me to separate out this term from this term unless I have a column like this, right? So the reason we have this ID column is to specifically separate out each and every record. So this is what we mean by uniquely identifying a record, right? So that means if I give a select command, right? So and I use this column and say where SID is equal to something, this should return only one row, right? So this is what we mean by uniquely identifying a record. Every record should be separately identifiable, right? So this is one of the basis of RDBMS. So there should be, so what they're saying is there should be at least one column, right? So it is okay if you have multiple such columns. Let's say you have something like Aadhaar number and PAN card. Both can be used. But when you're creating a table, there should be at least one column which can be used to uniquely identify a record in the table, right? So every record we should be able to reach individually. So that is what this key constraint says. And this is implemented using what is called the primary key, right? So this constraint is implemented using the idea of primary key. So the sole purpose of primary key is to uniquely identify records in a table. So normally when you create a table like this column called ID would be called the primary key, right? So this would be designated as the primary key, right? So key constraint says every record in the table should be uniquely identifiable. And in order to implement that, the concept that is used is called the primary key concept. So the moment you declare a column to be primary key, it automatically becomes unique and not null, right? Why should it be both? Why not just unique? Why should the primary key be unique and not null?
It is not unique, it cannot satisfy the condition or unique identify that.
Sorry, what was that?
It should be unique. It should be unique. Then only we can identify that record number.
Okay. So can I have multiple nulls here? If I declare a column to be unique, only one null is possible or multiple nulls are possible?
Not even one null.
Multiple nulls are possible, right? If you declare this as unique, multiple nulls are possible. Why is it possible to have multiple nulls?
Because it's an unknown value. Each one will have different values, which we don't know.
Yeah. So there is no way to say that this null is the same as this null, right? So whenever you need a primary key, it should be unique and it should also be not null, right? So it doesn't make sense to have null as the primary key. So unique and not null is automatically understood, right? So once you create a primary key, there is no need to separately create a unique constraint on it or a not null constraint on it. You just declare a column to be primary key and it will automatically become unique and not null, right? So this is what you call the key constraint. So through the primary key, we ensure that we are able to reach each and every record separately, right? So the next thing is what is called a referential integrity constraint. So when we talked about creating tables, right? So we said in the case of RDBMS, we store data in tables and we define a table and so that we can store the characteristics of this particular entity, right? So if I create a table called students, the columns that I will choose or the data that I choose to store inside it should be properties of this entity called students, right? So you have student ID, student name, age, which is a characteristic of student, right? So the course, right? So let us say I design a table like this: student ID, name, age, course, duration, and fee, right? So if I have a table like this, and if I enter data into it, right? So if I enter some records into this, what will happen is student ID 1, right? So Mary, 25, let's say MySQL, 2 weeks duration, right? And $100 fee. Second person, John, right? So he is 27 years. He is also learning MySQL, 2 weeks duration, right? So $100. Third person, George, right? Let's say he is 32. He is also taking the same course. So that means it's 2 weeks and $100, right? So what is the problem with this table? Is there a problem or is that fine? Do you see any problems here?
No.
This is fine.
$. Sign.
That is okay. That is okay. So here, what did RDBMS tell us? That when you create an entity called students, you should store attributes of students in the table, right? So I can say student ID is an attribute of students. Name is the attribute of a student. Age is the attribute of a student. Course is the attribute of a student, right? But then duration is the attribute of course, not the student, right? And fee is the attribute of the course and not the student. Do you agree? This fee is
Yes,
not,
ma'am.
right? So if you store data like this, what happens is you end up with redundancy. You end up with redundant data, right? So this is where your normalizing and all comes into picture. So here what we have to do is, see, if there are 1,000 students taking MySQL, for 1,000 people, I will keep saying MySQL 2 weeks, $100. And we have seen how much memory it will waste, right? So instead, what we have to do is, what RDBMS tells us is, take this out, right? So only keep the properties of the student in the students table. And then okay. So here, what you can have is something called course ID rather than the course, and create a separate table called courses, right? So here you can have a course ID, course name, duration, fee, right? And anything else that you want to store about the course should go into the course table, right? So here you can give the details of different courses. Let us say I have a course called C10, MySQL, right? So 2 weeks duration and $100. Then I have C20, which is data science. Let's say 6 months duration and $1,000, right? And C30, which is analytics. So all the details about, so here you see, let's say 2 months and $500, right? So here we see everything that I have stored inside this is a property of course. Everything that I've stored here is a property of the student, right? And here I will only mention the course ID. I will say this person is taking course ID 10, right? So these two people are taking course 10. This person is taking course 20, right? So, so now I have avoided repetition of data, right? I have avoided data redundancy. I am not for all 1,000 or 2,000 students. I don't keep saying MySQL 2 weeks, $100. Instead, I just have the ID of that. But now, in order to see what this course 10 is, I have to refer to a different table, right? So this is achieved. So here you would have created these as primary keys, right? So student ID will be a primary key here. Course ID would be the primary key here, right? Because this is what is uniquely identifying the records. But then I can create a key here, which tells you, see, if you want to know what the C10 is, you have to go and check out this table. So that is achieved using your foreign key. So this you will create as the foreign key, right? And you will say this foreign key references this column, right? So CID column in the courses table, right? So this is how you define your foreign key. So when you're creating this table, you will say this is the primary key, this is the foreign key, and this foreign key is pointing to this column in this table, right? So this is why we call it the foreign key. You are pointing to a foreign table. You're pointing to a different table, right? So this is your foreign key. So the table that contains the foreign key is usually called the child table. And the table to which it is pointing is called the parent table. So now what is the referential integrity constraint? So the referential integrity constraint says you cannot have any value inside the foreign key provided there is a corresponding record in the parent table. So I can put C20 here. I can enter a person whose course ID is C30. But if I try to enter somebody, right? So let's say Pat 25, who's taking course C70. This will not be allowed. Why? Because there is no corresponding record in the parent table. If you don't have a corresponding record in the parent table, then such records are treated as orphan records. There is no parent, and you cannot have orphan records. So this is enforced by the primary key foreign key relationship. So this is what we mean by data integrity, right? So I cannot put whatever I want into my table. This ensures that I cannot, I can't go ahead and bill a course to a student which is not even existing in this table. I cannot place an order for a product that does not exist in the product table, right? So that is what we mean by maintaining data integrity. We make sure that there is whatever value I am entering is valid data, right? So if you try to put something like this, it will say there is you are violating the referential integrity. Okay. Are we fine with this foreign key, primary key idea? And why
Yes,
we are
ma'am.
doing this?
Yes, ma'am.
Right? So this is the heart of RDBMS. This is why we call it relational database. This is where we define the connection between tables. We create separate entities, independent entities, and then we define the relationship between the entities using the foreign key and primary key. So when you look at a table, right, so there should be only one primary key in your table, but you could have any number of foreign keys, right? So I could have another table called department. Here I will have all details about department ID, the name of the department, the location of the department, or other details about the department, right? So here I can have another column called department ID, right? And this I can define as a foreign key, but this foreign key will be pointing to, here I will say this references the department ID column in the department table, right? So this references the department ID column in the department table, right? So this is this has now two parents. So department is one parent, and course, the courses table is another parent for this. So here also probably you have a reference to this table, for example, right? So let us say I have a course ID here. So this department handles this particular course, and this will be a foreign key, which is pointing to this table, right? So this is also possible. Or I could have a department ID here, right? Instead of two people pointing to courses, this would be better. So you have a department ID here, right? Which is also pointing to this department. So when you look at these two tables, right? So this is a foreign key pointing to department table, right? Let me take out this connection. Let's take out this connection, right? And let's say I have something like this. So now if you see, the courses table is the parent of students table, right? But then the courses table is the child of department table. Do you agree?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes,
So there can be multiple such connections. Just because this is a parent doesn't mean it's always a parent. With respect to the students table, it is a parent, right? But when you look at the connection relationship between courses and department, courses is the child and department is a parent. So you, according to this, right? So using this idea, you can have any type of connections between different tables, right? So this could be referencing this. This could be referencing some other table, right? So it is, there could be any number of connections. So this makes it very flexible when you are storing and fetching data, right? So, so hopefully we understand what we mean by primary key, what is a foreign key, and what we mean by referential integrity, right? So referential integrity ensures that I don't have some random data lying around in the table. Whatever data I have here has a valid entry in some other table, right? So this is called an orphan, and orphans are not allowed in the table. So because of this, what will happen is, let's say you have created your parent, child, everything properly, right? And when you entered records, you ensured that your integrity is maintained. You have not put anything like this, right? So you have put proper records. Now, after some time, what will happen if somebody deletes this record from this table? Right? If someone deletes this record from the courses table, we end up getting an orphan, right? Because when I inserted the record, it allowed me to insert because there was a corresponding record here. But later on, if somebody deletes a record, then I will end up having orphans. So because of this, the referential integrity constraint will prevent deletion of parent records. If you try to delete, it will say there is a child record pointing to this. So you cannot delete this record, right? The same is true if you try to do an update. If you change C10 to C100, we end up with orphans here, right? So C10 does not exist anymore in the parent table. So again, we end up having orphan records. So again, updation is also not allowed if there is a child pointing to the to that particular record. Okay. So from the parent table, you cannot delete or update records if there are records pointing to it. But this could be a big constraint, right? Because when you're using tables, right, you will be, think of a establishment like XLR, for example. So it's been there for quite some time, right? So probably 10 years, 12 years, 15 years. So you can't say that I will never delete anything from the table or I will never update anything on the table. Because when you create an application like this for the institution, right, you are going to keep using it for years together. So to avoid this kind of restriction, there is a way around, right? So the child can say, the child can give permission for the parent record to be deleted, but then it will give some condition, right? So the child can say, go ahead and delete the record from the parent, provided you cascade the same change to the child, right? So when you say cascade, carry over the same change to the child also. So that means you can delete the record here, provided you also delete a record from corresponding record from here. Now we don't have the problem of orphans, right? Whenever you take out a course, you take out all the students from the students table who had that course, right? So this is one option. So how does the child mention this? When you're creating the child table, you will also say on delete cascade. Right? So this means when you delete a record from the parent, cascade that change over to the child as well. If you do that, you are allowed to delete the records. If you don't mention this, you are not allowed to delete the record. Right? Similarly, the child can also say on update cascade. What does that mean? Whenever you update a record here, cascade that change to the child also, right? So make this also 100. Transfer that change or carry over that change to the child as well. So now the problem is solved. You don't have any orphans, right? So the course that was called the C10 earlier is now C100. Make it C100 here also, right? So now we don't have any orphans. But then the child should give the permission, right? Unless the child says you can go ahead and delete or you can go ahead and update, you cannot do an update or delete of the parent records. Is this fine? We'll see how to write the syntax for that. But for the moment, this is the concept here, right? Are we fine with this?
Ma'am, could you please explain cascade once again?
See, cascade basically says whatever change you do here, carry it over to the child, right? So why is it not allowing you to delete the C20? Because I already have a C20 in the child table. And if I remove this, then this does not have a parent in the parent table, right? So that was our referential integrity constraint. The foreign key can have only values which are there in the primary key to which it is pointing. So if the primary key has 20, 30 here, the foreign key can have only values like 20 and 30. It cannot have anything like 40, right? So now what will happen is if you happen to delete this record, if you happen to delete 30 from the parent table, this becomes an orphan. There is no corresponding record here, right? While inserting, it was there. So it allowed this. But after you inserted this, somebody deleted this. So now this will become orphan, right? Is that fine? Are you fine with that?
Yeah, okay, ma'am.
So now
Yeah.
what the child is saying is, see, I don't want to restrict you and say you cannot delete anything. So if you're deleting this, go ahead and delete from the child also. Now there is no problem, right? So we are still maintaining our referential integrity. The foreign key now contains only what is there in the parent table. This is what we mean by cascading the change that is done on the parent. Any change that you do on the parent, you cascade it or carry it over to the child. Similarly, if you are updating, right? So if you make this as 200, again, we end up with orphans. We end up having records here, which is not there in the primary key. So what the child says is, okay, go ahead and update. But if you're updating, make the corresponding updates on the child also. Carry over that change to the child also. So now the integrity is still maintained. Okay, but then it is the child who should give permission for the parent to be updated or deleted. Right? So parents usually have no idea about children. Only the children know about parents. Okay. So when you're creating tables, first the parent has to be created. And then you will create the child. And when you're creating the child, you will say, this column is a foreign key and it is referring to the primary key of this table. So if this table itself does not exist, you cannot create a foreign key. You cannot point to a table that does not exist as of now. Right? So when you are creating tables, you have to follow this order. The parent should be created, only then the child can be created. Right? The reverse is also true. When you are dropping tables, the child has to be dropped first. If you try to drop the parent, it will say there are child records pointing to you, you cannot be dropped. Right? Again, you will get a referential integrity violation here. So while creating, right, so this is something that you have to keep in mind. I think your assignment also gives you something like this. you have to make sure that the parent is created first, and then you create the child. If at all you are dropping a table, right, then the child has to be dropped first and then the parent. Okay. So let us see, we have a table called authors and books, right? So if you describe authors, you can see author is a primary key, right? So because it's a primary key, by default, it is not null and it is also unique, right? So there is a table called books, right? So here you see, this is a primary key. And MUL basically tells you that this is a foreign key, right? So probably not very intuitive, but then MUL is the one that says that author ID is actually a foreign key. It doesn't tell you to which table it is pointing, but it will just say that it's a foreign key and it's pointing to some table, right? So what I will do is I will drop these two tables and we will recreate it, right? So that we can see the syntax for creating, right? But let me show you what is there from authors. So I have some 8 authors, author ID and the name of the author, right? And if you look at the books table, so there are around 14 books written by these authors. And if you see the author ID column, right, you only have values here, which is also present here. You don't have anything called 10 or 20 or anything, right? Only values which are present here are also present here. So that is, if you try to insert something else, it will not allow, right? So let's first drop this and recreate it. Which one should I, okay, which is the parent and which is the child now?
Books is the child and I think the above one is parent.
Yeah, this is the parent. So which should I drop first?
Books.
Books.
Right.
Let's try dropping the parent and see what happens. Right, so I'll say drop table authors. So it says this is being referenced by a foreign key, right? So you cannot drop the table authors. So let's drop the child. And then if you try to drop authors, now you are free to drop authors, right? So nobody else is referring to authors, so you can drop it. So now let's create the table, right? So we'll say create table authors. Author ID. By the way, it's not necessary to have the same column name for the primary key and foreign key. You can give anything you want. So this is integer, and we will say this is primary key, right? And then name. Let's say somewhere care of 50 or 255 also is fine. So this is my parent table, right? So let's describe authors. So this is the primary key, right? So now when we are writing the child, when we are creating the child table, right? So we will create table books. So here book ID is the primary key, right? So primary key in the books table. Then you have title. Let's say where care of 255. And then we have author ID, right? So let me give it a different name, right? So let's say AID, integer, right? So now you can say in the next line, you can say the foreign key, right? The foreign key in this table is the AID column. And this references, right? So what does it reference? Authors table, author ID column, right? Optionally, Remember, when you're creating the child, you can give permission for the parent to be deleted and updated, right? So optionally, I can also say on delete cascade, and also if required, I can say on update cascade also. Both are optional, right? And notice that there is no comma or anything, right? So the whole thing, this is one foreign key definition. Okay, let me run this and then we will, hopefully there are no mistakes. Okay, so we have created the table, right? So now if you describe books, book ID is the primary key in this table, right? And AID is the foreign key, right? So what if you have multiple foreign keys in the table? So in that case, here, so let's say there is something called AID integer, right? So, and then let's say there is some publisher ID, which is also integer, right? So in the books table, you have book ID integer, which is the primary key. And then the title, right? So somewhere care of something. And then AID integer and publisher ID integer. This foreign key, right? So here we say AID is a foreign key. This references author's table, author ID, right? Optionally, I can also say on delete cascade, on delete cascade. Let's say I'm only using on delete cascade, right? Give a comma. So the next one you will define as foreign key, publisher ID, right? And this references publisher table, publisher ID, right? And optionally for this one, you can say on delete cascade and on update cascade. Right, so this is how you can define multiple foreign keys. So this whole thing is one foreign key definition. So that is why you don't have any commas here, right? So you shouldn't give any commas there. So here it means if you give this, it means you are allowing the publisher table to be, records can be deleted from the publisher table. You can update records in the publisher table also, provided the same change is done in the books table. Similarly, here you are allowing deletion on the authors table. You can delete records from the authors table, but you are not given permission for updation, right? So this is how you can create multiple foreign keys and specify on delete and on update. Okay. So now, are we fine with this? Are you fine with the syntax?
Yes.
Okay. So let me enter some records into the table because I just deleted it. Data analytics, SQL. So I will insert into authors. When I'm inserting records, first the parent records have to be inserted, right? Only then I can insert the child records. Right. Select star from authors. Oh, delect. Select star from authors and select from books. Okay. So now, if you remember, we had mentioned on delete cascade, right? So when we created the books, we said it is okay to delete from the parent table, provided the same records are deleted from here as well. So let's try to delete a record from this table. What should happen? This record will be deleted, obviously, but automatically all the records with AID1 will be deleted from the child table, should be deleted, right? Because we said on delete cascade. If you delete a record here, cascade or carry over that change here also. So that means delete AID1 from this table also, right? So let's see if that happens. So we will delete from authors where author ID equal to 1, right? So now if you check your authors table, author ID 1 is gone from the parent table. Now let's check the books table. What do we see? All the records corresponding to author ID 1 has been removed from the books table. And why did that happen? Because we mentioned on delete cascade. If you try it on your system, right, you will probably get an error and it will say you cannot delete a record. Did you try it on your database?
Yeah,
And it didn't allow you?
yeah, cannot delete or
Yeah.
update parent row.
Yeah, the reason is when we created the table on your using this practice tables, we did not mention on delete cascade. See, when we created the books table, we mentioned the foreign key, right? But we did not say on delete cascade or on update cascade. So when you created the child table, you did not give permission for the parent to be deleted or updated. Okay, that is why it is not allowing. When I recreated the table, I gave that option, right? So I allowed update and delete on the parent, right? So that is the difference between mentioning on delete cascade and on update cascade. So let's check the on update option also, right? So that means if I change, if I update this, right? So let us say I make, instead of 8, I make this 80. What should happen? These two records should also become 80, right? Let's try that. So we will update books, sorry, authors. Set the value of author ID to be equal to 80, where author ID is equal to 8, right? So now check the authors table. This has become 80, right? So now if you check the child table, you can see correspondingly this has become 80, right? So the reason is we mentioned on update cascade. Whenever you make an update on the parent table, cascade that change to the child also. Now we don't have any orphan records. Although we deleted and updated the parent table, we have not violated the referential integrity constraint. Okay. So one thing is it doesn't show, right? So when you describe books table, you don't know whether it has allowed, this says it's a foreign key, but you don't know whether this has allowed updation and deletion. So there is a very useful command called the show create. I don't know if I showed you this. Show create table and give the name of the table, right? So this will tell you what was the command that was used to create this table. This works for any table, right? If you want to know what was the command that was used to create the table, you say show create table and the name of the table. Can you see the create table command? And here you can see on delete and on update cascade. If you try it on your system, this will not be there. right? So this part will not be there. Can you check? Try this, show create table and the name of the table. Right? Did you try?
Yes.
You didn't open your workbench. Okay, so this is a very, very useful command, right? So when you're actually working, because any new table that you see, and if you want to replicate it on your system or something, just say show create table and the name of the table. It will tell you what was the command that is used to create this. Did we see this when we did truncate? Are you all there?
Yes, ma'am.
Yeah. When we talked about truncate, did we look at this command?
No.
No, ma'am.
No, ma'am.
So if you remember, what does truncate do? You remember this? If I say truncate books, for example.
It deletes all the entries and also
It
Recreate.
drops the table
recreate the-
and creates the table. So you should have asked, how does it create the table? Right, so to create the table, it needs to know the command that was used. Right, and where is this available, this information? This is coming from your information schema. Do you remember that? When you installed your system, there
Yes,
were
ma'am.
4 databases that were automatically created, right? And information schema stores metadata. So everything about the data, right? So what was the command used to create the table? What all columns are there? What is the data type? Everything is stored in the information schema, right? So truncate is able to recreate the table because the create table command is available here. So it will use that and create the table again. Okay. Right.
Can we update the table to undelete the cascade and update cascade?
You can do that, but you will have to give a name for the constraint. Add constraint, name of the constraint, and no. On delete only, I don't think you can do that. Right, so you can add a constraint, you can add a foreign key later on, but this I don't think it's possible.
Oh,
Okay, let me check. As far as I know, this is not possible. All right, so are we fine with one more thing? Other than cascade, right? There is also an option called on delete. Instead of saying cascade, you can say set null. Right. On update also, you can say set null if you want. So what this means is, don't delete the records. Right. So I don't want to delete the corresponding records. Instead, where is this? So when you delete a record from the parent table, don't delete the corresponding record, right? Just set this to null. Now you don't have any record pointing to this, right? Should I write again? So we had students table, student ID, name, age and course, and course ID. Here we had the course ID, course name, duration, and the fee. Right. So we had Mary, 25 C10, John, 27 C10, at 32 C20. Here we had C10 MySQL and so on, C20 data science and something, right? So now what we are saying is, instead of on delete cascade, I am saying on delete set null, right? So when I create this table, I say on delete set null, and on update also set null. So now what will happen is, if you delete a record from the parent table, this record will still be there, but this will be changed to null. This will become null. So now null is like, you don't have any record here which is pointing to something that is not existing, right? You don't have a course ID which is not there here. So this is null. It is understood that it's not pointing to anything. Okay. Similarly, you can also say on update set null. So instead of changing this to C100, these will be set to null. Again, if you look at null, it is understood that it is not pointing to anything in any other table. So this is also another option, right? So you can say on delete set null or on update set null, right? So these are the two options when you are creating your child table. Are we fine with all the constraints? Key constraint and referential integrity constraint.
Yes, ma'am.
The syntax also, if you understand what you're doing, it is easy to remember, right? Otherwise, it might be. Can you please explain the difference between primary key and foreign key? Okay. So difference between primary key and foreign key. Okay. What was it? Harshali. Okay. So did you understand why we need primary key here?
Yeah, for the unique record.
To uniquely identify a record, right? It's not that unique. Yeah, you want to identify each and every record. So you need a primary key, right? So every table should have a primary key. Now coming to this, right? So if you have something like this, if you create a table like this, you can see there is a problem with the redundancy, right? So we are unnecessarily repeating this information for all the records that are there in the table. If there are 1,000 people taking MySQL course, what will happen? 1,000 records will have MySQL 2 weeks and $100. So how much space are we wasting? For duration, I might have declared this as some varchar of something, right? So that many bytes I will be wasting. Fee also I'll be wasting some so many bytes, right? Can you see this is a waste of space? Yeah.
Yes, ma'am.
Yeah, I think somebody else had that doubt. Harshali, are you there? Yeah. So if you write something like this, right? So we keep repeating information that is not required. Again and again, we are saying the same thing. And the reason that happens is because these two columns are not properties of students. Rather, they are properties of this thing called course. So instead of this, what we are doing is, let us move this to some other table. Right? So everything related to course, we will move to the course table. right? And then in the students table, we will only have a reference to the course table. We won't keep repeating MySQL and all, right? So instead, I will just have one column called course ID here, right? So let us call it course ID. And here you will say the course ID is C10. This person is taking course C10. This person is taking course C10. This person is taking C20. But now, how do I know what is C10? Right? What is C10? What is the course? How do I find the information? Where is the information available about C10? So when you're creating this, right, so you should also say, if you want to know what C10 is, you have to refer to the CID column in the course table. So this is actually pointing to the primary key of some other table. So such a column is what you call the foreign key. Right, so foreign key is actually pointing to the primary key of some other table. And that is also one point I don't know if I mentioned. You can only point to the foreign key of, primary key of some other table. You can't point to anything else, right? So here CID is the primary key. Here student ID is the primary key. So this will allow you to uniquely identify a record in this table. This column will allow you to uniquely identify a record in this table. But this column tells you that this C10 is actually, the details about this C10 is available in some other table. So this is pointing to a foreign table, right? So this is pointing to a foreign table in the sense something that is not this table. So that is why you call it the foreign key. So it says, if you want to know what this C10 is, I am actually referring to the CID column in the course table, right? So now if you want to get details about this, you know where to go. There will be so many other tables, right? So there will be a table called department. There will be faculty. So what is this pointing to? What is this number pointing to? Right? So let me take out that C, for example. Let's take out the C. Let's say we have only 10, 20, 30 here. Here also you have 10, 20, 30. How will I know this 10 refers to this or it is referring to this? So when I'm creating this table, I should say, whatever you see here is actually coming from this table. Right? So that is what the foreign key tells you. From where is this data coming? What is this pointing to? Okay. Is that fine?
Yes, ma'am. Got it. Thank you.
Okay. Fine. So before we move on to one more, the next topic. So we will also see about auto increment, right? Whenever you talk about primary key, you can auto increment it. So till now, we have put only one type of object into your database, and that is a table. Right? So table is one object that you can create inside your database. But there are other objects that you can create, right? So you can create something called a sequence object. You can create an index, which is another type of object. You can create a view, which is a different type of object. You can have stored procedures, functions, triggers, right? So these are all different objects that you can create. So all these objects like table, index, view, and all can be created using the create command, right? So create table, name of the table. Here you will say create index, name of the index, and so on. Sequence is one object which doesn't have a create command in MySQL, right? You cannot say create sequence MySequence in MySQL, right? So you can do that in Oracle Informix and all. They support this create sequence object command. But in MySQL, you can only specify auto increment, right? So when you say auto increment, it actually creates a sequence object and attaches it to the primary key of the table. Okay, sequence can only be attached to the primary key. So what this will do is, it will prevent, it will allow you to, so if you have a table like a patient's table that we created, right? So patient name, DOB, time of admission, right? So this was the table. And we said that this is being updated by multiple people, right? So somebody from Bangalore will be updating it. Somebody from Dubai will be updating it, right? So every time, and usually, not usually, definitely your primary, this PID will be defined as the primary key. And because this is the primary key, we have to ensure that this is unique and not null, right? So whatever value is getting entered into this should be unique. So a person who's putting a record into this, right? So let's say there are already some 100 patients in the table. So when this person is entering the next record, he has to see what was the last value that was entered. Then he has to give the next value, right? He has to enter the record saying 101 patient is getting inserted. When somebody from Dubai is entering, he also has to check what was the last value that was entered. And then when he is entering the record, he will make sure that he puts 102. Right? Only then you can ensure that PID is unique and of course not null. You are giving a value. But to ensure that it is unique, you should know what values are already entered into the table. So you should make sure that you're entering something which is not there already, right? So this could be a tedious process. Every time before inserting a record, I have to select the last value, and then I have to make sure that I'm entering the next value, right? So it could happen that both people are looking up at the same time. So when this guy checked it, last value was 102. When this guy checked, this is still 102, right? So both of them might try to insert 103. And one of it is going to fail, right? So to avoid all of this, this headache, right? You can create a sequence object and attach it to the primary key column. So a sequence, as the name suggests, can only generate a sequence of numbers, right? A series of numbers or a sequence of numbers. And it remembers the last number that was generated, right? So if you create a sequence object, attach it to the primary key, then this person need not worry about the primary key. They will enter details about all the other values. The sequence will automatically generate a number and assign a value here. And it will remember the last number that was generated was 104. So next time somebody inserts a record into this, it will put the next number and remember that this is the number that I generated and put here, right? So these people don't have to check what was there earlier and then try to put the next value and so on. So this makes the task of entering values into the primary key a little easier, right? So your sequence just generates next numbers and remembers what was the last number that was created. So the thing is, a sequence can only be attached to the primary key, right? You cannot attach it to any other number. So how do we create a sequence? You just say auto increment, right? So when you're creating the table, let's create a table here. So we'll create table, my tab, ID, integer. Let's make this the primary key. And we will also say auto underscore increment, right? And let's have another column called name, which is where care of some 30 or something, right? So let's have a small table. So now if you describe my tab, so you can see auto increment is mentioned here. So whenever you see auto increment for the primary key column, it means that you don't have to provide value, right? So this is already being supplied by the sequence, so you don't have to give value for it. So when you're inserting records, right? So you'll say insert into my tab. My tab, you only have to give value for the name column, right? Let's say our Tom. So now if you select star from my tab, the primary key value, right? So the value for ID has been automatically supplied by the sequence object. Now with the sequence remembers that the last number that I entered was 1, right? So when anybody enters the next record, it will automatically give the next from the sequence, which will be 2, right? So let's insert another record. Insert into this name, instead of Tom, let's give it as John. Now you can see it has automatically taken the next number, right? If you insert multiple values, John, Jim, and James, right? So 2 records have been inserted and it has automatically given the next value, right? So this is what your auto increment does. It gives values for the primary key automatically, right? And it is just a sequence of values that is generated. What happens if I say insert into my tab values 10 and Lara? Will it allow me to do this? Can I give my own value?
Yes.
Yes.
Okay. So now if I insert another record, what will happen?
11.
So if you give this, right, it will continue from this, right? So it will remember the last number and it will continue from where you left off. It will not try to fill in the blanks, like it won't go back to 5, 6, 7, 8, right? It will continue from the last value that is entered here, right? So what if I delete from my tab? Now all records are gone. Now if I insert, what value will be there for Jonathan? Or let's say somebody else. Let's insert John. What value will I get?
12.
12. Right? What if I truncate this? Again, there is no record in the table. Right? And if I insert John, what will be the value?
1.
11.
1.
Why 11?
Sorry, 1.
1.
Yeah. Okay. Why 1?
Because table will be empty.
And it's a first
is-
record.
Yeah. Here also table is empty. But the difference is here when we did delete from my tab, we only touched the records inside it, right? So the table itself was not touched. But when you say truncate, we dropped the table and we recreated the table. So when you recreate the table, the sequence also gets recreated. So that means it will start from 1 onwards. right? So when you truncate, the table plus all the objects on the table will get dropped and a new table is created with the new sequence on it. But if you're saying delete, only the records inside it is deleted. The sequence still remembers what was the last value, right? So if you delete and start inserting records, it will continue from where it left off. If you truncate and then insert a record, it will start from the beginning, right? So this is your, this is about your auto increment, right? But there are limitations here. Auto increment can be assigned only to the primary key, and it can only work with integer values, right? So these are the restrictions or limitations, you could say, of primary, of auto increment. Okay, right. So now, yeah. So we have seen, we talked about constraints, right? So we talked about two types of objects. We still have half an hour, right? So let us look at what we mean by a view, right? What's a view? Any idea?
No, ma'am.
Okay, you can think of a view as a virtual table, right? The reason it is called virtual table is because it does not take up memory, does not need memory. So this is a very, very big advantage. This is the main advantage of using views, right? So that you don't need memory. So you can think of it, so you would see that it is defined as a window on the data, right? So basically you want to see only the thing that you want to see. So let's say you have a table called employee, right? So you have employee ID, first name, last name, then job, salary, commission and all that, right? Commission, department. But let's say you are interested mostly, right? So if you look at a real-time table, you will have at least 30-35 columns inside it. And only few of those you will be interested in most of the time, right? So in that case, you can every time say select first name, last name, job and salary, for example. Instead, what you can do is you can create a view, right? So that view will be selecting only first name, last name, job and salary from the table. So this is why we call it a window on the data, right? So we are looking at, so I create a view called my view, where I am selecting only these columns from the table. So once I create this view, whenever I say select from my view, I will see only this part of the data, right? So that is why we call it a window on the data. So you might have n number of records, right? But you will be looking at only this portion of the table. So it allows you to simplify the way you query data. Once you create a view like this, you don't have to keep saying select first name, last name, job and salary, right? Instead, you will just say select star from my view. Star from my view, and automatically you will see this part of the data. But the reason it is called a virtual table is because it's not taking up any space. It's not like, don't think of it like it will take this part of the column and put it somewhere else, right? It's not like this. F name, L name, job, salary, right? And all the records, if there are 1,000 records, there will be 1,000 entries here, right? So it doesn't work like this. It does not make a copy of the data and store it somewhere else. Don't think that this is my EMP and this is my view, right? So this space is not taken. This value, these details are not replicated anywhere else, right? So it does not take up memory. Every time, whenever you say select star from my view, it is actually selecting first name, last name, job and salary from the my EMP table only. So now if you tomorrow you add more records to this and you say select star from my view, you will still be able to see all the additional data, right? So let's create a view. How do we do that? We can say, is this? Okay. So let us say select star from my EMP and limit it to some 10 records, right? So let us say I'm only interested in this part of the data. I want to see only the email, or I want to say the last name, email and hire date and job ID, right? So I can create a view by selecting this. Or I might be interested in first name, last name, and the job ID and salary, right? So this is the window that I'm creating. So I'll say select, create a view, my view, right? Create view, my view, as select, what all do I need? First name, last name, job ID, and the salary from my EM, right? So once I create this, now I can say select star from my view. And it will show only the first name, last name, and salary of the person, right? So here there are 106 records. Tomorrow, if I add some records to the my EMP table, right? So let's say I add some 10 more records to my EMP table. So whenever I say select star from my view, it is actually selecting from the my EMP table, right? So when I created this table view, there are only 106 records. But it doesn't mean it will always show 106 records, right? Because what is happening here? Whenever I say select star from my view, actually this query is getting fired. So anything that you add to the my EMP table will be visible here. If you add 10 more records, then the first name, last name, and job ID and salary for those 10 records will be reflected inside this. Right? So the best way to think of a view is like a named select. It is like we are giving a name for a select command. So this select command is given a name called my view, right? And whenever you say select star from my view, it is actually executing this command. So this is called the base table, right? So we are fetching data from the base table only. There is nothing called view. There is no separate storage happening, right? We are still fetching from the same disk. And you can see a view is treated just like a table. So whenever you say, normally we say select star from table, right? So, but here we are saying select star from the view name, right? So if you say show tables, where is my view? See, you can see, yeah, my view is also being treated like a table only, right? So you can select, insert, update, whatever you do on a table, you can do on a view also. Right? So what will happen if you insert a record through the view? What if I say insert into my view values let's say some first name, Tom Hanks, actor, and salary is 10,000. What will happen now? Where will the data go? Yeah, we don't have any table called my view, right? It's just a select command. So whenever you say insert into my view, the actual data is going into the base table only. Right? So here it will have null value. Here it will have null value, right? But this goes into the base table, right? So whenever you are inserting record through the view, the actual data gets stored in the backend table, right? So that is why we call it a window on the data. So if you think of your table as the room, and you have a view which is a window, right? Anything that you insert through the window will actually land up in the room only, right? So there is nothing stored on the window itself. So whenever you do insert, update, or delete through the view, it is affecting the base table, right? So let's take our small table called authors and let's create a view on it. So I'll say, let's say what is there here. So let's start from authors. By the way, if you have these small tables, right? So this my view, probably you feel that it's not very useful, right? So why not just write a select? Why do we need something like a view? But remember when we wrote our joins and all, right? So we have complex queries. Do you remember your left join? Then we did some formatting and all. Do you remember that? We had the movies table and we had the members table, right? I think we wrote a left join and then we had an if null and all, right? So let us write it. Select movie dot title, movie dot category, then members dot first name, and we had an if null also, right? If null members dot first name, replace it with a dash, and we had this an alias name, and then if null dot last name, replace it with a dash as L name, from movies as MB, left join members as MM, on movie dot ID is equal to dot movie ID, right? So this is the query that we had written. So instead of typing this all the time, why not create a view on it, right? So I can create a view. I'll call it rentals because we are thinking of it like a rental business. So I can say create view rentals as select this, right? So now I don't have to, if this is a query that I'm frequently executing, I don't have to sit and type this all the time, right? So instead I can just say select star from rentals. I still get the same result, right? So probably now you can appreciate why having a view is very useful, right? It's not anything to do with performance or anything, but it makes your life very simple, right? It allows you to type simple queries. You create a view and keep it, right? So anything that you frequently execute, you just say select star from that. Okay. So now let's try to insert records, right? So for that, we'll take a small table. We'll take our authors table so that it is easy for us to insert. So I'll create view, a view, right, as select star from authors, where author ID is less than 15, for example. So if I select star from a view, how many records will I see? If I select star from a view,
All the records.
I have this condition. My view is created based on this condition.
6 records.
Instead of 7 records, your view will select only 6 records, right? So this is your view. So this is the view that you have created. So whenever you say select star from a view, this is the data that you will see. Anything beyond that, you will not see, right? So this is the condition based on which the view is created. Okay. Now, let us say select star. Right. So we see the 6 rows. So now, let's try to insert a record through the view, right? So although we insert through the view, it should actually land up in the authors table, right? So let us say insert into a view values. What do you say? Let's say 17 and some author, right? So Tom Hanks.
Ma'am, double A.
Values Tom Hanks, right? So now if I say select star from a view, will I see Tom Hanks?
No,
No.
Yeah, why?
is greater than 15 CID.
Yeah, because the command we are executing is actually this, right? But if you check your authors table, you see Tom Hanks has actually been stored in the table, right? So inserted through the view, but the data actually landed up in the base table. But here what we have done is we have tried to insert a record which violates the condition based on which the view was created, right? I have inserted a record where author ID is actually greater than 15, and it is allowing me to do that, right? So sometimes you may not want to do this. Because one of the reasons that you write view is, of course, to select only the data that you want to see. But your DBA might want to create some views so that he wants to restrict access, right? So we have our department table, sorry, my EMP table, right? If you select star from my EMP, limit it to some 10 records. See here in the my EMP table, you have details from people belonging to different departments. And anybody who has access to my EMP will be able to see details of people in all the departments. So what if you want to restrict access, right? So what the DBA can do is he can create a view for people in each department, right? So he can create a view called department 60, right? For example, create view DP60 as select star from my EMP, where department ID is equal to 60, right? So now if you say select star from DP60, you will only see details about people in department 60. So like this, he can create some 11 views. And then what he can do is he can give permission. He can give permission on department 60 to people in department 60. So these people can see all the details about people in their own department, but they don't know anything about a table called MyEMP, right? So they cannot view the details of people in other departments. Similarly, if you create something with the department 90, give access to department 90 to people in that department, right? They will have access to all the records from their own department. They don't know anything about people in the other departments. But then, what if a person in department 60 tries to insert a record where department ID is equal to 100? Will it allow or not allow?
Allows in the main table, but we cannot see in department 60. We-
Although you cannot see in department 60, you are still allowing people to enter records belonging to other members. They can delete records belonging to other people. They can update records belonging to other people, although they don't have access here. Somebody from department 60 might as well say, delete from my department 60, right? Where you can insert records, you can delete records where department ID is equal to 100. So these people are allowed to modify or insert records belonging to department ID other than 60. So you may want to prevent this, right? So this kind of defeats the purpose for which you created this department. So if your intention for creating the view was to restrict access to certain records, then you should not allow people to insert, update, or delete anything that violates the condition based on which the view was created. I should not be allowed to insert a record with the department 100. I should not be allowed to update a record with the department 100. I should not be allowed to delete a record with department 100 through the department 60 view, right? So if you want to restrict that, what you can do is, when you are creating the view, right? Let me drop the A view, drop view A view. And now when I'm creating it, right, when I'm creating this, I will also say with check option. So if I do this, right, so now if I select star from A view, I see all the records which have values less than 50, right? If I try to insert a record now, insert into A view values, let's say 19, right? Tom Cruise, 19. This will not allow you to do the insert because you are trying to do something which violates the condition based on which you created the view, right? So this will now fail. Earlier it was allowing, right? So now it says check option failed. But as long as you follow the rule, the condition, right? If you make it 9, this will go through, right? So now you are able to insert into the view. You are able to insert into the table through the view because you are following this condition. You are not violating this condition, right? So now whatever you inserted will be visible in the view, right? And it will also be visible in the table, right? Are you clear about what check option is?
Yes, ma'am.
So if you want to restrict this, then you can create the view with check option. If your intention is just to simplify a select, right? So you don't want to keep typing a big command over and over again, just create a view, right? So don't bother anything about check option. But if you want to use it like a table and you want to restrict access, then you have to go for with check option. So this view that you have created, right? So this A view that you created even earlier, right? So without the check option. So that is called an updatable view. So updatable view is the view through which you can do insert, update, and delete. But not all views are updatable, right? So only if you are selecting columns directly, right? So let's say you have a table called the My tab, where you have columns C1, C2, C3, C4, C5, right? And let's say you created something called My View, where you have C2, C3, C4. You have selected C2, C3, C4 only from this table, right? And you have created a view. This view is updatable. So whatever I insert, right? So if I insert into My View, right? I say insert into My View values 10, 20, 30. Where does the data actually go? It goes into the base table only, right? So 10, 20, 30 will go into the base table. These two will be null values, right? Although you are inserting through the view, the actual data goes into the backend. But let's say when I created my view, right? So I have created, instead of C4, I have created C4 into 0.2, like we did for salary, right? So this is what we call a derived column. Right? So I have created a view by taking a derived column. Now, if I say insert into My View, values 10, 20, 30, where will this 30 go?
Thirteen to 0.2 will get, right? Instead of
No,
C4.
but the column is only C4. Right? C4 into 0.2 is 30. What will you put in C4? It will not divide it by 0.2 and put C4 here. Right? So what is 30? 30 is actually C4 into 0.2. So what is C4? C4 should be 30 divided by 0.2 or something. But MySQL will not do that calculation. So if you have a derived column like this view is not updatable. I cannot see here. It's a simple case, right? I would have done something complicated here. So if you have something like this, you can create a view, right? But you cannot, that view is not updatable. You cannot insert, update, or delete through this view because these columns don't exist in the backend. Okay. So as long as you are selecting columns directly from the table, you can do insert, update, delete. But if your select command, right? So when you're writing this query, right? How did we create this view? Create view A view as a select statement, right? If the select statement has anything special inside it, like having a derived column, or you have a group by operation, just give me 1 minute. Okay. So if you have anything special in your select, like derived columns, group by, order by, what else? Some group operation, like sum, right? So sum, count, average, and all. Or if you have joined two tables. So anything special, right? So if you have a distinct keyword. So anything special in the select command you have, you can create a view, but that view will not be updatable. Not updatable. Okay. So this is it about a view. It's a small topic, right? So it is mainly used for convenience. It makes writing your queries simpler. right? So once you write it and keep it as a view, you can always select from that view. You don't have to keep typing complex queries. One more reason is you might want to hide some data from your end users. So in that case, you create a view by selecting only a portion of the data, and that only you will show to people, right? And the view can be treated exactly like a table, but not all views can be used for update, delete, and insert. It is updatable provided we are doing a direct select of the columns. The moment you have anything special in your select command, it becomes not updatable, right? So the view is not updatable, but for select purpose, in order to select from the view, you can create a view with any kind of commands that you want. Okay, so are we fine with the view?
Yes, ma'am.
Yes, ma'am.
Right. So the main point to remember is this does not need memory, right? So this does not take up memory. So that is why it is called a virtual table. Okay. Main advantage of that, you can create as many views as you want on a table. It will not take up extra space. Okay, so let's stop for today, right? So tomorrow we will look at index. Oh, a transaction is pending, right? So we will look at transactions and then index. So once we are done with this, we can move on to the programming part. And window functions, the most important part. Okay, fine. Let's look at transactions and indexes tomorrow.